It says that four rods are joined to form a rhombus such that this end is fixed and this end is moving with velocity v towards right. Our aim is to find velocity of this point. Now the easiest way to do that is, as this is fixed, we can choose this as origin. Then coordinate of this will be what? X comma 0. X would be this distance. What would be coordinate of this point? Well, if you draw this line, you can see this line will cut this distance into two equal halves. So if this is x, this will be x by 2. So coordinate of this point will be x by 2 comma, let us call this distance y. So now as this point moves, this point will come down, at the same time it will go right side. So this will also change, this will also change, right? So let us calculate the x component of this velocity of this point. So Vx, that will be differentiation of x coordinate of this point, which is x by 2, isn't it? So that will give me half will come outside dx by dt. Now what is dx by dt? That is the rate at which this x is changing, meaning the rate at which this point is moving this side. So dx by dt is nothing but velocity of this point, which is v. So Vx we found. Now we need Vy. Vy means what? The rate at which y is changing with respect to time for this point. To find that, let us relate this y with this x by 2 and this fixed length, which is L. So here if I write L square will be equals to, from Pythagoras theorem, x by 2 square will be x square by 4 plus y square. Now since L is constant, if you take differentiation both sides, this will get 0. Here you will get 2x dx by dt divided by 4, and here you will get 2y dy by dt, isn't it? This 2 and this 4 will cancel to give you 1 2. So this will give you x by 2, and dx by dt is this velocity of this point, 2y, and dy by dt is what we want, which is vy. Vy here means y component of velocity of this point. So if I take this one this side, I will get 2y vy is equals to minus x by 2v. So your vy will be equals to minus x by 4 y times v. Okay. Now they are asking the velocity of this point when this rhombus becomes a square. Meaning right now this angle is acute like this, but as you move this point, it starts increasing, right? This angle starts increasing. So when it becomes 90 degree, that time we want to know the velocity of this point. And you know, when this rhombus will become a square, this and this will be equal in length. So x by 2 will be same as y in length. That means in place of x, I can write 2y here. So if I write 2y here, let me calculate this side. So my vy will be equals to minus x will be 2y v by 4y. And therefore this will give me minus v by 2. So vx we got v by 2. Vy is minus v by 2. So the net velocity of that point will be under root vx square plus vy square. Let me call this point as a, or let's say b. Let's say this is a. Then velocity of this point b will be under root vx square plus vy square, which will be root 2 v by 2. So this will give me v by root 2, right? Another method to solve this question is when this rhombus becomes a square, this angle will be 90. And if I draw these lines, this will be 45, 45, isn't it? Now this point is fixed, remember, and this point will go right side also, left side also, so resultant will be somewhere here. So this velocity component, let us write Vx, this is Vy, and this point is going this side with velocity V. Now since this length of the rod is constant, velocity of this point along this rod must be same as velocity of this point along this rod. So the components of velocity of these two ends along this line of the rod must be same. Meaning if this goes this side with some velocity, this also should go this side with same velocity. So here what is the velocity of this point along this rod? Here Vx I have shown, so this will be same as this angle, and this is 45, this is perpendicular to this is perpendicular to this, so this is 45, this is also 45, so this will be Vx cos 45 is 1 by root 2. Similarly this Vy will have velocity component here along this length of the rod, which is Vy by root 2, isn't it? So what is the velocity of this end along this line? Vx by root 2 this side, Vy by root 2 this side. So net velocity is how much? Vx by root 2 minus Vy by root 2. That is velocity of this point along this line. That should be velocity of this point along this line, but this is at rest, so that velocity should be 0. So from here you got Vx equals to Vy. Similarly, this length of the rod is also constant, isn't it? So velocity of this end along the length of the rod, again this is 45, remember, this is 45, so this will be V cos 45, which is V by root 2. So this velocity V by root 2 must be equals to velocity of this end along this line. Now this is also 45, this is also 45, so this component of Vx will be Vx cos 45, and here because of this Vy there will be one more component here, Vy by root 2. So Vx by root 2 plus Vy by root 2. You can cancel root 2, and already I have shown Vx and Vy are same here, isn't it? So therefore this will give me 2 Vx. So Vx will be V by 2, which is also Vy. And then you can find V of this will be under root Vx square plus Vy square, which will be root 2 V by 2, which is V by root 2, isn't it?